Okay, so we're going to start section 5.8, which is dealing with quadratic inequalities, but we're going to do a little bit of a warm-up with some of our properties of inequalities. And so we have three examples here. I'm going to do these real quick, but just remember that what we're doing here is we have an AND statement, so that means that with an AND, we're going to have a graph that's connected, we're pointing in the same direction. With the OR inequalities, they're going to be pointing away from each other. So when we solve for p in number 1, we get p, and then we're going to have a -2, but remember we switched the inequality. This one we're going to add 3 to both sides, and we have p is less than or equal to 4. So then if I was to graph that, I'd plot 4 and -2 because they're both equal to. I use a filled in circle and I connect the two lines. So for it to be a solution for both the first one and the second one, we need to have any number between -2 and 4, including 4 and -2. Now with your statement, I'm going to do the same thing. I'm going to solve for the variable. So when I do this, I'm going to divide by 2. There's no negative that's being multiplied or divided out, so we leave it as is. I'm going to solve for z for the other one. Subtract 7, so that's going to give me a positive 9. Divide by 9, and I have z is greater than 1. So in this example, we have our -3, here's 0, and here's 1, and we have an OR statement, and there's no equality, and notice the arrows point away from each other. And with this one, I can pick either or because it just needs to satisfy either the equation on the left or the equation on the right. So either of these numbers will work for either one of the statements. Example 3, our variable's on the other side, but that shouldn't matter. We still solve. We keep the inequality in the same perspective and read from the variable on. So in the first example, the variable was on the left. So what we did is we said p is greater than or equal to -2. In this one, we're going to start at the variable, and t is greater than or equal to 2. We're going to go ahead and solve this one. I'm actually going to add 4 t to both sides, because then that gives me just a t on the one side, so it's already solved, and I have 17. Then I'm going to subtract the 3 from both sides, and I get 14. So for this example, I have, once again, I'm going to read from the perspective of t and go towards the letter, so t is greater than 14. So if I go ahead and graph this on a number line, I'm going to plot 0, 2, and 14. This is a generic graph, but t is going to be greater than 14, not equal to, and t is going to be greater than or equal to 2. Okay, and so I actually made a mistake on this one, so let me go ahead and erase this. Apologize for that. It actually should be subtracting 4, so let's go ahead and redo this one. I have, I'm going to just completely redo this. So if I subtract or add the 3t, so I have 17 plus 4t is less than 3 minus 3t. I'm going to subtract or add the 3t, so that's going to give me 7t, and then I'm going to subtract the 17 at the same time, and that's going to be a -14. So divide by 7, and I have t is less than -2. So the graph for this guy I'm going to put over here, and I have 0, -2, and 2 were both my solutions. Okay, and so now I'm going to graph it. I have less than -2, and then I have greater than or equal to 2. Okay, so be careful with your shading, filled in circles versus not filled in circles, and make sure you're going in the right direction, and don't make the same mistake I did on something that should be very, very easy to do. And this is just a quick warm-up on solving compound inequalities and graphing them.